Hey, welcome to Coffee Compiler Club. We're here today talking about how boating is like standing in a freezing cold shower, ripping up $100 bills, or maybe compilers or language runtimes or something. I don't know what. All being recorded live, be up on YouTube within a couple hours. Ask by starting opening spiel. It's all good. I don't have any set agenda. I don't know that there's much I can throw out. AA update is very short, basically slowly plowing all the theory things into the production side things that seems to be making forward steady progress. So more and more exciting use cases or test cases are running, but I'm a ways to go yet.
I had something that I wanted to say to Levo. Maybe he already understands this, or maybe he doesn't. But so to a first order approximation, right? The performance of something running on hardware is dependent only on the dynamic execution stream and the values in registers and in memory. And with C, given infinite time, you can get exactly the dynamic instruction stream and the values in memory that you want. So given infinite time, you can do anything that you can do on a computer, even in theory, in C. So this notion of faster than C, it doesn't really make any sense unless you add other constraints like faster given bounded engineering time, or faster given like fewer security issues or things like that. It's a more complex.
I meant specifically about the standard library like fopen and fread, because you have to copy it. And if you just use POSIX calls, you could just not copy it.
No, but you can do that in C as well, right? So
yeah. But obviously, I meant faster than the C standard library, not C itself, but the standard.
Yep. Just wanted to say that if it wasn't.
Yeah.
I'm trying to start my video.
So I wanted to say though, I mean, there's such a thing as idiomatic C. So like, you can write, amazingly fast C, but it's going to end up just being inline assembly. It's not actually going to look like C code. So
my claim was more only in theory. So I'm including inline assembly as part of what is possible.
Right. But what I'm saying is that if you actually look at what this optimized, amazingly fast code looks like, it looks like inline assembly. It doesn't look like C anymore. So like when people say as fast as C, they're saying you write the dumbest, stupidest C program you can think of. And that is what they're benchmarking against. It's not that they're benchmarking against
that
this
too.
hypothetical C program that you've written with infinite time.
And years ago, C was actually referred to as a portable assembler, for what it's worth.
Mm-hmm.
It was designed at a time when compilers weren't that great, and if you had crap code coming out, then it just would like completely suck. So I think.
Yeah, I mean, keep in mind that the term compiler hadn't existed until a decade before it. I mean, C was 1972. First compiler was like 1957.
Yeah.
1956, Grace Hopper or something, I don't know.
No, Fortran 4.
I wonder if anyone thought undefined behavior and portable makes sense, because that's a little borderline.
Didn't we talk about this a couple weeks ago?
Yes, that's why it's on my mind.
And decided that you and Cliff were always wrong.
Yes. We might have decided something differently, but yeah. You happen to decide that Cliff and Levo are always wrong. That's fine. I have used C many times to port a language to assembly, and there was always undefined behavior, and I didn't care. It didn't.
So I want to hear from Yorick, because it looks like he keeps busy with this Cranelift stuff. I'd love to hear.
Oh yeah, you're doing like a rusty thing here.
Well, So my compiler, it was and still is using LLVM as the backend, or at least that's what I'm working towards. Actually, yesterday managed to get it to a point where I can now finally run my entire test suite without segmentation faults. That took, I think, 2 weeks of fixing a lot of stupid bugs. A lot of them were like, in my runtime library, a function would return a struct, but in LLVM, I still had it typed as returning a pointer. And then certain cases it will work, sometimes it will not. And yeah, those kind of bugs are annoying to find. But anyway, Along the way, I was like, hey, you know what? Let's take another look at Cranelift. Because at that point I had, I think, implemented about 80% of my backend in LLVM. And I basically learned enough to develop an opinion on specifically LLVM in general, but also this wrapper library that I was using. So I was like, hey, you know what? Let's take a look at Cranelift. Specifically, I noticed that there was a pull request that was adding support for checked integer arithmetic. It wasn't implemented before. And I needed this because so it was saying, yes. So by default, Cranelift only supported wrapping integer arithmetic, and I needed a check so I could produce an error upon integer overflow without having to implement that myself for addition, subtraction, division. Well, division is quite easy. Multiplication is a nightmare, as far as I understand.
For overflow?
As far as I know, for signed integer overflow multiplication, it's quite a pile of code you need to write to handle all the cases. And I'm sure if you've done it before, it's not that hard, but there's a work in progress backend for the Rust compiler that uses Cranelift. And they had to do this because it wasn't supported. And I remember looking at it, and the multiplication code was quite daunting. So I was like, I don't know enough about this. I'm not going to touch it. But there was a pull request adding support for this. So I basically built that version of Cranelift and experimented with it. I think I made it about 40-50% before I gave up. I think that my findings were that overall the library was nicer to use because it was a Rust API, whereas LLVM is very much a C++ API. And in this case, there's a Rust wrapper slapped on top. But it does things kind of like not Rust-like. For example, this wrapper library, all the functions, they take an immutable reference to their data structures, which means that on one end, it's easier to use because you don't have this sort of issue where Rust doesn't allow multiple mutable borrows and things like that. A better way to explain it's mutability in Rust is sort of an exclusive lock or like a write lock. You can have many readers, but you can only have one writer. This LLVM wrapper basically just uses only readers. And then it relies on, well, even though LLVM under the hood still mutates things. There's a lot to be said about that. I don't like it because it kind of, makes it easier to mess up. And there's some cases with the LLVM library, certain operations that are marked as safe can actually segment fault your compiler. An example there is if you use the API to look up a LLVM intrinsic, like a FABS signed into whatever. There's an intrinsic basically to convert a float to signed integer. If you look that up, but you give a name that is incorrect, it will just segment fault your compiler. And I believe technically
that's a safe seg fault though, right?
Yeah.
Well, so as far as I remember, Rust basically states that if something can segment fault your program, it is by definition unsafe. Which, you could argue if that's right or not. I am of the opinion that at the very least it should be a note, and probably it should be marked as unsafe. But you could argue for hours about that. So I'm like, it is the way it is. But that's kind of an issue. You run into these surprising things because at the end of the day, it is a C++ library that is being wrapped. Well, in this case, using the C interface, but potato.
So it's by definition unsafe.
Yeah, and so there are parts like LLVM's get element pointer instruction. It is wrapped. It's exposed in basically two ways. One where it sort of a simplified implementation that works only for structs. That one is marked as safe. But the raw instruction is unsafe. And as far as I understand, there is just no way to make it safe because it can crash if you give it invalid indexes, but a lot of the times those indexes might not be known at compile time. So there isn't really a way you can, short of coming up with a completely different API, it's quite difficult to make that safe. And so that function is marked as unsafe.
It's been a while since I looked at Cranelift. I think like maybe 3 or 4 years ago. But I was wondering about the multiplication. Can't you just like emit code that does the multiplication and then check the carry flag and not
Not the carry
assume?
flag.
So that's the thing. It had an instruction for, I think, add with carry, and I think sub with borrow, because they decided that the term is different for whatever reason. I believe there was none for multiplication. And I recall finding some issues where they were stating that these functions, so these instructions were basically deprecated. Had been for like a while, but they were still there. So it was this kind of stage where it's like, okay.
The add with carry was deprecated?
Yeah, because they wanted to replace it with basically better checked instructions. They just wanted to get rid of all this carry borrow bullshit.
All right, fine. I mean, T2 admitted add with carry as the default way to get 64-bit arithmetic on a 32-bit machine. Like the compiler is hard of hearts.
From what I understand, this is basically a case of we have something, we want something better. We don't know yet what, but in the meantime, we've just marked it as deprecated to sort of highlight this.
Haven't actually removed it.
I feel like C is easier than Cranelift, but that's just me.
Well, so the API in general was fairly straightforward to use. I actually found it more pleasant than the LLVM API. There were, but that was kind of the double-edged sword. So in LLVM, you have to provide type information with certain operations. Now, if you have versions prior to 15, I think, you have to do this in a whole bunch of places. Starting with 15 and 16, it's the difference they made is the pointers are now untyped. So
yeah, that kind of bit me.
So you can have basically the pointers now just typed pointer, and then when you do loads and stores and things like that, that's when you specify, hey, this is the type that I'm loading. In Cranelift, there are no pointers; they're just integers. And so on one end, it's nice because you don't need to maintain this pile of typing information just to feed it to the IR. On the other hand, you have to do all your offset calculations and alignments yourself, and this is where it's kind of lacking maturity-wise. There was
like you had to specify layout packing yourself.
Well, so in the LLVM API, let's say you have a struct of like, let's say 3 fields, right? In the LLVM API, you say, hey, load this pointer as this struct, and then access index 2. And then LLVM will just figure out what the offsets are, take into account alignment, your architecture, whatever.
Right, he does the packing.
Yep. Right. Cranelift doesn't do that. You need to figure that out yourself. So you have basically an integer which represents your pointer address. You have a load instruction, and then you need to figure out, hey, relative to that integer, what do I actually need to, load offset wise?
Oh, okay, fine.
And it's not that big of a deal, but it is kind of annoying in terms of code wise. Yeah. Then there were certain things where let me say this correctly. I think if you wanted, so I had code for dynamic dispatch. And essentially what it does, it dereferences a pointer into a object header. It then takes the class pointer and through my implementation, it dereferences that. And then the method table is basically slammed into the class. So if you have, a class with say 200 methods, that class is size A, whereas if it has 10 methods, it's size B. So there's no extra pointer you have to go through.
Right. Same for hotspot, actually.
Right. It's a variable array at the end in C, basically.
Yeah, variable array at the end. Yep.
So the dynamic dispatch basically does 2 pointer dereferences, object header, the class, and then it has to calculate an offset in that class to figure out the method.
Right.
That slot has a structure with 2 values. It has the pointer to the native function to call and a hash value, because I'm using hashing for dynamic dispatch. Hashes are all pre-computed at compile time, but it still needs to compare, like, hey, if I need
perfect hashes,
right?
The Bloom filter or perfect hashes?
No, so it's not. I don't know what you would call it. Technically, probably still hashing. Based on the article, essentially what happens is each method name is assigned a globally unique identifier for that name.
Okay. Yeah.
Meaning if 2 different types have a method called print, they both get the ID 4, for example.
Mm-hmm.
And this uses the state-of-the-art hashing algorithm of, I used to do just, ID +1. Now I'm using FNV because it's a little more consistent. Previously, depending on ordering, you would get different hashes and slightly different compiled results. Now I'm using FNV, and then to handle conflicts, it just does +1. But point being, you have a map of all your unique function names to their hash codes. Then I maintain whether or not per type, if there are, say per function, if there are collisions. So if any given type might have a collision. And then what it does at the dynamic dispatch call site, it has your standard hashing loop with linear probing.
Okay.
Except the hashes are pre-computed at compile time. They are slammed directly in the code. So there's no FNV, whatever, running at runtime. And the probing loop is only inserted if you statically determine there may be collisions.
Gotcha. Okay.
And based on my rough statistics, that is only the case in about 5 to 10%.
Okay. All right.
So in most cases, the dynamic dispatch code is basically 2D references,
Yeah.
a bitwise AND of the hash with the table size.
Yeah.
And those table sizes are rounded up to power of 2. So I can use
Okay.
binary AND instead of the modulo operator.
Right. Yeah.
So all things considered, it's pretty performant.
You have to load the method. Now that you've got the method, you still want more load to jump to it then?
Yeah, so it is 2D references and then an indirect function called to, so 2D references, a bitwise AND.
Yeah.
Then you do, you need to translate that into an offset.
Yeah.
And then you have to do an indirect function call.
Yeah. Okay. That's the same. You got one more step in there than Hotspot does when doing a virtual call, but we're not doing dynamic lookup. I mean, virtual.
Right.
It's a load jump register.
Right. So it's all things considered not too bad. Now in LLVM, this is fairly straightforward. Well, fairly straightforward, as in you you generate the code for the dereferences, the bitwise AND, etc. And then you basically stick that into a get element pointer instruction, and LLVM will calculate the offsets for you. So you essentially get element pointer instruction where you say, first index is 0 because this is confusing. You're indexing through a pointer, so the first index has to be 0.
Yeah.
I can explain it if you'd like.
Then your second index is basically to the start of your method table offset. And then the third index is your index into that table. And then LLVM will sort of translate all of that into an actual offset relative to your class.
Right.
Yeah.
Still numbers.
In Cranelift, you have to do all of that yourself. And it is kind of annoying to generate the code to dynamically calculate pointer offsets at runtime. Because you end up with basically dereference, and you have to do a integer add on the address. Sorry, what?
That was annoying for me too.
Yeah. So that particular case, you could argue like, oh, it's not that difficult, it probably isn't. But this is where I sort of saw the differences between Cranelift and LLVM. Cranelift is very low level. And I think that is very nice if you have an extra IR in between that does all those offsets calculations for you. So in theory, let's say you stick LLVM IR in the middle, but instead of having LLVM compile it, you translate that to Cranelift.
Oh, geez.
It's ironic that you find it low level than LLVM.
Well, so I'm not suggesting you actually use LLVM IR in the middle, but something that takes care of this sort of platform differences. And then I think it's not too bad. It is, as a library, still very immature. The documentation is still god-awful. I have found a lot of cases where the documentation was either straight up incorrect, as in they referred to, hey, this is used in this function, and that function didn't exist anymore. Examples didn't work, or the documentation was literally just describing the function signature. So you have a function that's, add int and int, and the documentation is like, this function adds int A and int B. You're like, thanks. That doesn't tell me anything I didn't already know.
Yeah.
This kind of reminds me why I don't like abstractions, because it seems to me just learning something else or just going straight assembly could be easier.
Easier for what?
At the end of the day, I think that's a trade-off. So in case of LLVM, for example, the issues I mostly ran into with the LLVM backend is that the wrapper documentation is very limited. And that is annoying. Like in other cases where it's examples, they don't work anymore because the API has changed, or the examples use certain types, but it doesn't say where you have to import those from. And then sometimes those types have been renamed. So you have to kind of figure, okay, what is the sort of up-to-date version of this example? The benefit you have there is that LLVM itself is very well documented. Now, the tutorials, Kaleidoscope as such, a bit of a hit and miss, but the reference documentation in general is excellent. The problem is you have to know what to search for. So if, like an example, the code I was generating to check if a floating point was infinite was not correct. Because what I did is I basically created two literals of floating point, sorry, negative infinity and positive infinity.
Right.
And then I think at the time, I don't know, I wasn't entirely awake. So I was like, if you do an equality check and then you bit and, either one of them will be 1, so that you can check the result. So the code generates basically negative literal, positive literal. Does negative literal equal?
Isn't there only like positive and negative infinity? There's not like nans, there's a bazillion, there's only the 2 infinities.
Well, so the instruction I generated did take care, like, hey, if it's nan, we spit out false. But anyway, the code I generated was not entirely correct. And so my question was, okay, how does LLVM have anything for that? Do I have to write it myself? And that's where it's sometimes a little tricky to find in LLVM. And the solution that I've taken and that I've seen recommends basically, you compile C code with Clang to LLVM IR. So you can sort of figure out, okay, what do they generate?
Yes.
And so through that, I found, hey, they use the LLVM FABS intrinsic to make the value positive.
I was going to say that.
And do an equality check on that.
I thought I was certain C2 did this.
Right. And in hindsight, that makes perfect sense. I'm like, why didn't I think of that? But then when you look up that intrinsic, there's a pile of documentation saying how to use it, which options there are, what the cases are. So it's that initial finding of the documentation that can be a little tricky. Once you have it, LLVM's documentation is great. Like, nothing to complain about. But yeah, and because I'm using a wrapper library, you do have to sometimes figure out, okay, this wrapper library, what function of the C API does it use? What does that translate to in the C++ API? And okay, what is the corresponding documentation of that? That can be a little annoying. But I've found interesting enough that for the most part, I didn't need to do that. It was fairly natural that, if I want to generate integer subtraction, there's a function called build integer subtraction. Shocking. That's what we should use, right? It's just where these more specific things like this floating point stuff or checking if a float is non was a little tricky because LLVM has a float compare instruction and it has a whole bunch of like the operation you specify. So it can be, float equality, float lower, greater, etc. But then they have two versions of that, a ordered float comparison and an unordered one. And that's where it got a little confusing because I was like, wait, what's the difference? And it turns out that, if I say correctly, unordered ones, they will spit out false if any of the values is none. Or the other way around, I don't remember. But either way, one of those you would use to check, hey, is this float a non? So that's where, you have to dig through a bit and figure out, okay, which to use. In Cranelift, it's basically a lot of cases like, yeah, we don't do that. You have to generate all of it yourself. Good luck.
Just do it yourself. Yes. I tried to burn all those float NAND comparison brain cells a long time ago.
Right. And so I think at the end of the day, Cranelift in its current state is, it's okay if you are a developer on Cranelift, because you will know exactly what to use, what the state is of things, etc. But based on the documentation and just like a lot of APIs felt sort of haphazardly thrown together. One example, if I can think of, in LLVM, you have a builder type that you use for generating your instructions. And then I think you need to have a corresponding context. And I believe that context you can reuse between different functions or modules. It's sort of like a cache, I guess. In Cranelift, if you want to build a function, I believe you have like a function builder and then a function builder context, but there's also a third context and you need all three of them. But then the function builder context, I believe, needs a mutable reference. Sorry, the function builder needs a mutable reference to the function builder context. I might be confusing it, but point being, you end up having to create like 3 structures, but you can't easily pass them all around because they take references to each other. So you have to like sort of somewhere at the top, keep some of them around and pass them down. And as far as I understand, there isn't really a good reason why they are separate. It's because they want to be able to cache some data between functions. So they said, let's create a separate type. But then the way they've built the API, there isn't really a reason why there couldn't be a single type. And you just have to call some function at the end, like finalize or flush cache or whatever you call it.
Yeah.
So you end up with things being separate types for the sake of being separate types. And I really hate those kind of APIs because you end up with, you have a function builder, bean, and whatever all laying around when it could just be one thing.
Well, I have to admit that the C2 API was, never intended to be used by anybody else under any circumstance. And then, more compilers and more runtime bits and more concurrency and parallel this and whatever. And the API slowly growed over time and it was never very pretty.
Yeah, so I think in the end there, my conclusion was, I made it about halfway through, I think, maybe a little less. The problem there, one, the library it was immature. No, that's not necessarily a bad thing about the developers or whatever. It's just not there yet.
Yeah, right. Yeah.
And in contrast, LLVM, part because it's been around for 20 years, but also because literally every computer science student works on it. It just has a lot more for going for it.
Yeah, I get it.
The second thing I found is once I was about halfway, because you can't really test my code until everything's implemented.
Yeah.
I was a little worried that it was going to take a lot of time. And then I still had to figure out how I'm going to produce object files because Cranelift doesn't do that. You need a library for that. Then you need to link it. Well, that's the same in LLVM. You invoke your C compiler, whatever, but it still had to be done. And a couple of other things. So at about halfway, he was like, you know what? I'm going to save these changes as they are, but I'm going to leave it because at this current rate, I suspect it's going to take me probably another couple of weeks.
Yeah.
And I will most likely reach the conclusion I've reached at this point already, which is that it's not really suitable. And then finally, the big thing is right now, Cranelift is only used for wasm time. I don't know how the Webassembly, I don't know the acronym, how you properly pronounce it. Is it WASM or WASM? Or, anyway,
yeah.
Webassembly. There's a project. Yeah, there's a project Wasm Time which uses it, and then there is what's the other one? There's another one that uses it optionally, and then the third big project is a backend for the Rust compiler, but that one is sort of unofficial. It's not part of the Rust project. And what this means, it currently very much has this possibility that if the main company supporting this goes under, so does the development. Sure, some people pick it up, but good luck finding people with the knowledge to do this. There's 5 or 10 of them, and they probably just got laid off. So I'm like, I feel very uneasy using that as a very core component of your compiler. Right? It's like you ship a laptop and you use some hobby OS that came out last week. It's like maybe not the best idea. So I went back to LLVM. And basically based on the past knowledge, sort of cleaned up my code and ended up putting sort of an extra wrapper in between, which is a little funky because it means if you basically the idea I had is instead of my code generated directly using LLVM, it uses my own wrappers. They are still very much LLVM like. But the idea is, if inevitably the LLVM API changes, I don't have to go and change it in 500 different places because they now need an extra argument. Because that was big change going from LLVM 14 that I was using before to 15 because they had this untyped pointer change. So now I needed to make like 5,000 changes in my code. And I didn't know if it worked until like a few days later.
Trust no one.
Well, yeah, and the idea here is, if
Alright.
LLVM changes, or if I maybe decide to scrap LLVM, in theory, it's a little easier.
Mm. But
That was the
it's always
funny thing we hit with like both the compiler C2 ABI and the GC ones until we had like 3 unrelated GC algorithms implemented. The ABI was changing each new GC. Like we had a GC bedridden system. Okay, we needed a new one. Let's make an ABI so we can swap them out easier. Well, that new ABI was just like passed through the old setup anyhow. But the new one wanted something different, so we did a little screwing around. The old and new could go. As soon as the third one came along, we completely missed out on some bunch of stuff. We had to go hack a bunch of other things. How the fourth one came around, the ABI was actually almost plausible, like you could actually kind of move it in. But it took like 3 real unrelated GCs get an API that you'd use for GC. And yeah, I feel like the compiler side of things never even got that close because we just had C1 and C2, and they never unified till I did it at Azul, and openjdk never picked that back up.
I mean, if you design an API for less than 3 use cases, you're going to get wrong where you need the abstraction anyway.
Yeah, that's the problem. Right. And LLVM's been around long enough. They have a lot of unrelated languages and unrelated backends, so they've got an ABI that's at least somewhat.
But the idea here, I don't think it's to, I don't know, generalize for multiple users. It's to provide a layer that separates you from the changes in like in one library. So LLVM changes and evolves and doesn't provide any guarantees on backward compatibility of the APIs. And like we actually have to deal with that. We have a regular merge and we pick up changes from LLVM on a regular basis, like every few hours. And yeah, every once in a while things change and we need to fix our code. And we actually thought about, okay, if we introduce this kind of layer, maybe it would have been easier to maintain this, though we just use LLVM APIs directly and just deal with the changes when new changes come. So that's just to limit the number of places you need to change your code when the API changes.
I guess I was agreeing with Yorick that Cranelift will likely undergo more radical ABI changes in the future than LLVM will.
Yeah, so in my case, the API is still very much LLVM-like. So it's not like there's a big abstraction around it. It's more simple things. For example, the REPL library that I use, if you want to do let's say integer subtraction, it's called like the function called like build int sub or something. Takes 2 arguments, int a and b. Then it takes a third argument, a string, which specifies the name of the temporary to use in the LLVM IR. And if you leave that an empty string, it will just generate one for you. I basically, in all cases, I didn't specify because there's not really a benefit to it, but it's still there. So you end up with all these function calls where it's like, argument ABC, empty string. And so I have a wrapper where it's essentially the same thing, but minus that empty string, and it just sets that, for example. So it's simple things like that, just to basically get rid of the noise and not so much to have this abstract reusable thing. I think one final thing to mention there, then I'll shut up and let somebody else go at it. Initially, I was quite worried that the debug info, producing debug info in LLVM is quite tricky. Couldn't really find clear info on this, and the APIs provided by this REPL library, they suggested there's going to be a lot of noise involved, like, oh, you need to set up this thing and then that thing, blah, blah, blah. Like there's functions to create essentially type info in the DWARF debug info. I don't know exactly what it's used for. And so initially Mike was like, crap, now I have to generate all those type names every single time I want to have like decent debug info. But no, it turns out it's actually surprisingly simple to produce enough debug info to get stack traces with accurate line numbers. Currently, it's like, let's say 10, 15 lines of code that I've copy pasted in like 12 places because I've yet to generalize that into a single thing. But that was something where I started on like a Monday. I was like, oh, this is probably going to take me a whole week. And then like, I think by Tuesday morning I had it working. I was like, wait, that was all. And, and now I have basic debugger support. You can't print variables or anything just yet, but at least stack traces work, which is enough to get my test suite working because I need stack traces for that. Yeah.
Cool.
I recommend giving the values names. It will be handy when you read the IR and need to figure out what's going on.
So
Yeah, and that's very early on. That's what I used it for. Specifically, what I did is I took the names of my registers in my IR and then generate these LVM names in the form of like R with the numbers, say like R14 equals. And then we could sort of trace back like, oh, this line of LVM corresponds to roughly this line in my IR. But I found that basically once I started running this on like larger chunks of code, the IR became so noisy that debugging it became a pain anyway. Yeah. And that's part because my IR currently is quite noisy. It produces quite a few basic blocks. And so if you look at a function in its LVM IR, this is, it's like 15 basic blocks. They jump all over the place, and it's basically possible to figure out the flow anyway. It gets a bit better when you optimize it, because then LLVM just basically takes a shotgun to most of your code and it's like, get rid of this crap. But then I would have to cycle between different optimizations levels while developing it, because I don't have a flag for that yet. So eventually I just figured, you know what, I'm just going to use generated names. It's fine, whatever.
One thing
so
that
you're able to crawl your stack. Are you able to follow the pointers from the stack to the heap and really get a sense of where all the memory is? Or
so I don't use a garbage collector or anything like that. It is essentially the Rust model, compiler inserts, freeze, and whatever. The stack trace stuff, the really only reason I needed it is because my unit testing library obtains a stack trace to figure out where your unit test was defined, so that in the event of an error, it can say, hey, your test defined at this place failed on this particular line, instead of just saying there was an assertion failure. Alternatives would have been to perhaps have some sort of test syntax built in, and then as you compile it, you inject your location information. But I didn't want a dedicated syntax just for writing unit tests. I just wanted to be able to use the language, like regular functions, closures, whatever. Which means
doesn't C do something like that? There's a like magic file name, file number that becomes whatever it is.
Pound line macro.
Under file, under line, under. Yeah.
Yeah, something like that. And some other language had that, and I thought about that too. But the thing then is, if you were to write your unit test, you would have to pass those values as arguments.
Yeah. Yep.
Or as a language, you have to support default arguments. But then you have to make sure that when you use those sort of special constants, macros, whatever, as a default argument, they translate to the values at the call side, not where the argument is defined. Right. So if I define my function file A and I say, hey, the first argument is line and it defaults to underscore line, which is magic constant set to the line number. You want to make sure that that's a line number where that function was called, not where it was defined.
Yeah. I just pass it as a regular argument to the test harness. But give up.
Yeah, but So either way, there are a couple of different options you can choose. The option I was using at the time was using stack traces. So I was like, you know what? I'm not going to chase my semantics too much. That's a separate
stack traces work.
Separate 3 months of work. So I'm going to do stack traces because I need them anyway. Like if there's a panic, I need to print them.
Yeah, you need them anyway. Yep.
And that's, I ended up using a library that does this, a Rust library, because that takes care of all the different platform shenanigans. And like, oh, on macOS, sorry, on Linux, we use the command adrid to line or whatever it is to translate certain dwarf info to like line info. But on macOS, that doesn't exist. You have to do it differently and blah, blah, blah. So it's like, I took a brief look at the dwarf standard. I was like, nope, I'm not going to familiarize myself with that at this stage because that's like 5,000 pages long. I will defer that to a library, and that works. And then I think I had to do some minor cleaning to filter out stack frames from the runtime library that I'm calling into, and stack frames introduced by this Stacktrace library itself. And I had to do some minor cleaning of the mangled symbol names, because my symbol mangling scheme is very simple. It's _I and then just basically the full name of the thing. So I _IM, so I can know if it's a method or something else. And then when I had the stack trace, I would basically strip off that prefix, and anything that didn't have it would just get thrown out. And then you're left with just the stack trace of your generated code.
Mm-hmm.
Yeah, that was one of those things was like, yeah, it's going to take me a week, and it took me basically a day.
Nice. I did all that stack trace stuff in C2 back in hotspot land, but it was part of everything else to it, parsing bytecodes. It was buried in there. It was a month plus. I was also doing the parsing and a bunch of the generation. It was a piece of work.
Has anyone here done things with dwarf? Yeah, because I've been wondering how to translate an instruction pointer to where it is in a function, and I just decided not now. Like, it seemed difficult.
I know how to do it in hotspot C2, but
Matt,
not
Arthur,
dwarf.
any experience with dwarf?
So we do generate debug info, and we have some code that actually takes the debug info from the object file produced by LLVM. We decode it and put it into our own format, so later it can be used in VM. I don't know how we decode it, but it is possible, and we do have this mapping between PCs in the compiled code and back to the debug info.
I'm certain there's a Linux specific function that gives you the backtrace, but I think it's called backtrace, but I have no idea how to do it myself. And I'm not depending on the standard C libraries, or I'm not depending on the standard C library. I don't know if this is part of the standard C library for Linux, but like a new C, but yeah.
Do you want to do this programmatically, just using standard C library? Do I understand you correctly?
Well, originally what I intended was to track, to give a printout if a person did an integer overflow in my language. And I wanted to support using libc and not using libc, but like it's not a big deal. I can just use libc for like a period, because I'm not sure how many people want to build a binary that works on all distros. There's probably only one that they care about, and I could probably just get away with just using the standard C library every time.
If you work with libc and musl, you can get surprisingly far.
I wonder if musl does it. I have no idea. Like, I don't know if backtrace is like GNU C or something else that it links in, or.
Though, do you really need the debug info for this? Because when your front end generates this addition and the check, you know the location of the original language where this code is coming from. So in the code that reports the overflow, you can actually emit some information.
Yes, I was thinking it might be nice to not include so much information in the binary. So like if a developer doesn't want because I was like thinking some people might just want to ship their binary without debug information and then get like a core dump or something, and then use their own copy to like figure out the information, but like it's something that I don't have to do. Like instant overflows, who's going to care about that right now?
So I think it's two separate questions. One is providing debug info and making it easier to, I don't know, understand what's going on in a debugger. And yeah, you need to, if you're using LLVM, you need to emit the corresponding metadata, and LLVM will take care of that. But for
Yeah, I do that.
Reporting details on where like an overflow happened, or basically any error reporting, if you know this in your front end, like you have all the information about the context from there. Though you frame it interestingly that having the debug info, in theory, you can do this kind of reflective, I don't know, access to, okay, what is my debug info, and trying to report.
Yeah, like I have all the instruction pointers. I should be able to like look up what function it belongs to.
Yeah, I think probably you'll need to have your own runtime function that that parses the debug info, the dwarf part of your object file, and
Yeah.
maps your PC that was passed into this function into something that your code can handle. I don't know if there is a standard function.
It would be, I think it's DWARF specific, and I'm pretty sure GNU C has something for it, because I know I used something like that before.
Yeah, for us, this information takes a long path. So LLVM generates dwarf. We take it, we parse it into our own internal representation that actually strips away a lot of details. We just keep the information about VCI.
So why do you use dwarf? I mean, I know LLVM will do it for you, but because if you're translating it, why have it in the first place?
We are using LLVM, so that's what we get from LLVM.
Okay.
So we get an object file with all the sections, and then we parse it and put it in our VM structures. And we also we take stack maps, for example, and we encode them into our VM format that is understood by our GC and our runtime. We do the same for dwarf. Obviously, code we copy and put it into the proper structures.
I have a question. Who put in the tinyverse.org tag in the links, which was an interesting read?
No, it was not me. Someone
threw it in, which is fine. It's an interesting read.
Maybe Mark.
I added that when Yorick was complaining about too many dependencies, and that dependencies going away can cause you pain.
Perfect.
And I feel like tinyverse is a good summary of every dependency you add is a liability and a time bomb.
Yes. All right, I highly approve, or I highly agree, or something. Yes.
I constantly find myself in the tension of I am scared of dependencies and I would like to build something that actually works. And I know if I write everything myself, I will never finish and I will never build anything that works. And if I npm include something and suddenly have 7,000 dependencies, that one of them might break me.
Oh God. Oh, I did the npm
so if you have
for a while.
7,000 dependencies times how many might break per year times how many might be still maintained.
I think my app had 3,000 dependencies, but literally 3,000 from just pound including handling. But I was picked up React, and I picked up MobX, and I picked up Flow, and I picked up one or two other things, and then their transitive dependencies came to 3,000.
I had people tell me that
the npm churn, where everybody broke something on a daily basis, and you had to push forward or backwards dependencies to get a stable build. And then I did that churn for like a couple months, and that was nightmare. So I locked down and accepted a certain set of bugs that were known bad bugs, but I just lived with them because I couldn't do the churn, and I got some work done for a while. And then, I tried to pick the churn up every 6 months, and you churn for a month. after you picked it up again to get things stable. Then you said, okay, good enough. And a new set of bugs. They're all different from the old bugs, but they're not bad. And you locked it down, lived with those bugs. The churn model there is just a nightmare.
Dependencies suck.
Yeah. No good answer on that one.
I had people tell me that no one will use my language in compiler because I don't want a package manager, but you know what? Dependencies suck.
You have to have something, but by gosh, it's so easy to get driven down that rat hole.
I had a tech lead at Google once who described software to me with an analogy I thought was useful, which he said there's two ways to develop software: pylons and surfing. And if you're using pylons, you drive them deep into the earth and they can never move again.
Yes.
And you just have to accept that whatever's good about them is good and whatever's bad about them is bad, and you can't fix it.
Right.
Or you can be surfing, where you're constantly bringing new things and things get up and you move much more quickly, but you have to have engineers who are constantly pulling in things and constantly adjusting things, because you can never stop moving. Because if you stop moving, you are going to wipe out.
Yeah, right. You can't stop. Yes.
And that's why Blogger had no new features for 10 years and 4 full-time employees for 10 years, because what they were doing was constantly doing the surfing of, as each piece of infrastructure disappeared out from under Blogger at Google, they migrated to the next one.
Oh, geez.
Does
And
that
like,
cover
as long as you're
writing
surfing,
everything
you can never
yourself?
stop. But if you're building on pylons, you can never update. So pick your poison.
Yeah, I just read it myself.
Yes. Well, I was following through some of the following links and realized that was a rat hole. I'll have to go offline.
It also depends where you are in the food chain, right?
Yeah.
The closer you are to the end of the food chain, so to speak, if you're building an application and no one is reusing anything that you do other than yourself, it gives you a lot more flexibility in how you pick things. And I don't mean flexibility like you should go one way or another. It's just you can, right? But the further upstream you get, the less choices you have, right? So for a lot of libraries and modules, you don't have a choice. You can't depend on things. I think I've told you guys a story before, but there was a point where we used Apache, either Sax or DOM, sorry. One of our employees with a Russian accent would call them Sax and DOM. And they changed the API between 2 versions, and the APIs were incompatible, meaning you couldn't link to the 2 versions. You had to pick one or the other. And at the time, they were like, I think it was WebLogic at the time, used Apache, whatever. And since we used it, we had to use the same version, but there were 2 different versions, binary incompatible. So what we had to do was actually, to ship, we had to drop the dependency and actually build our own XML parser just to ship. So it's like sometimes pylons are the right decision, right? But they can't be outside we ended up having 0 external dependencies other than the JVM itself.
When you
So the question is, what would be the middle ground?
Well, no one's found one yet. I'm with Aaron here. It's pylon.
I would say that the dependency are not customizable. They're just, you cannot reach out and customize them and configure them without.
So we're taking an interesting approach with ecstasy design, in that the artifact from a compile is a point in time slice, but that's not what goes into the repository. So think of it like you do a CI build, and that's like this version of the code, and it doesn't have any dependencies in it per se, like they're all pointers by name or whatever to the dependencies. And so you put it through your suite of tests, and you're like, I like this build, it looks good, I'm gonna bless this as a stable build, right? I'm not giving a version number, whatever, but just stable. And it goes into basically a combination of all accepted builds, and that becomes the artifact. So the artifact is actually sliceable by version, by time, whatever. And it's all delta compressed, of course, because it's 99% identical between versions. But what that means is that at link, we basically defer all that mess to link time. So when you go to link, you actually have every supported version available. So if you're pulling in a library that says, well, I only work with version between 2.1 and 2.7 or whatever, and you have something else that says, I need nothing less than 2.6, but I'm happy with 3 and 4. And you basically have to do a SMT. What does that
Yeah,
stand
you're
for?
just saying SMT solver, but
Yeah,
it sounds like it's easy.
Satisfiability modulo theories. Yeah.
you basically do SMT at link time to figure out what versions of dependencies are
Yeah.
necessary.
Mhm.
So my experience here was that the surfing would get you, somebody needed a new version, that new version would cause a bug in an old version of something else that
And you can ask
for another reason. And so you had strictly conflicts, and they weren't well discussed because people were still discovering them.
Yep.
So you didn't know, and you put together what you thought was a stable combination, and then you found the bugs. And then about that time, somebody else was starting to report them as well. And then
Right.
you had to juggle something here or there until you came to a personally acceptable set of known bugs. And that was what I declared as the next stable version. I didn't have any,
Yeah,
the
so we have,
information that says that I had to have version X or greater showed up much later from when I was actually, in the middle of the surfing pile. I didn't have that information.
Yeah.
2 months behind me, somebody says, oh yeah, everyone knows that you have to have version X or later, but 2 months ago, no one knew that.
yeah, so we
You
have
guys can-
metadata that lets you basically say, avoid this specific version or avoid this range of versions, et cetera. So the idea being you would then attach that metadata and push that back into the repository, and then that would downstream avoid those conflicts.
Well, what I'm saying here is that when I started doing that, so this is all manual, I got to the point where I would have no possible acceptable solution. And so I really had to have in some future date, I will be able to have a resolvable one, but as it stands now, I have to pick poison A or poison B, bug X or bug Y, whichever one I prefer the least. And then 2 weeks from now or a month from now, the next version of the lib comes along and it solves this bug, and I can get rid of the choice between X or Y bugs. But mysteriously or secretly to me, a new set of conflicts has arisen that I'll discover in my testing in a little while that no one knows about yet.
Yeah, I don't think everyone's going to be happy with my solution. It's probably going to be a small percentage of people who will be happy. But the way I was planning to deal with this is have as much basics in the core library, like your hashing maps, like probably XML and JSON, and then just try to convince people to stick to the standard library. Just have a good standard library that everyone understands, and try not to use dependencies. Like whatever that's, I've seen people like, I've seen a project that had like tens of millions of download. And I thought, why isn't this just the standard of that language? So I'm just going to try to introduce many things into my standard.
Yeah, it may be more complex than that.
So I think I agree there.
People won't be happy.
Sorry.
All right, you're first.
I was going to say I agree with the the idea of a sort of batteries included standard library.
Yeah.
There are some things where it's always up for debate, but I think like standard library should have your data structures, your cryptography, whatever. But then you have higher level things like, should it have an HTTP client? I am of the opinion, yes, it should, because otherwise you end up with 15 of them. Like if in Ruby, for example, which I worked with for years, there's like 20 different HTTP clients because, well, the standard library has one, but it was so god awful, nobody wanted to use it. But then there's more things like, oh, should the standard library have a module for OAuth, for example? And that's where it kind of gets muddy.
Yeah.
And I think a second thing there is how you resolve dependencies, like the algorithm you use for it. The sort of go-to approach today is, you have an SMT solver, you give all these complex version constraints where it's like, oh, I need this library at least this version, at most that version, except these two versions that are known to be broken. Right. And then you can maybe support different versions of the same library, but then you end up with a program that links like the same CSV parsing library 4 times because your dependencies cannot agree on what version to use. So there, I'm a fan of the this idea of a minimal version selection that Go uses. I implemented it for Inco. I didn't base it on Go. I actually based it on the implementation of a language called Futhark, if I pronounce it properly.
I'm not familiar. Oh, I know Futhark though. Well, I'm not familiar with Go's thing here.
So the concept is very simple. You list your dependencies and you say, I need at least this version. That's it.
But you're
and
only,
they then follow semantic versioning. So if you say, I need, CSV parser 1.4 at minimum, and somewhere down your dependencies, somebody says, I need version 1.6 at minimum, it will pick 1.6.
But you can't say, but I cannot handle 1.6.
No, you then have to bump your minimum version beyond that.
Yeah. Well,
and the system hinges on people, using semantic versioning for the numbers, so it can select.
Yeah.
Like my implementation, for example, if you have 2 different dependencies that depend on, let's say, version 1.1 and 2.2 of the same library, it will say, hey, the major version is different. Per semantic versioning, that is incompatible. We will not solve this for you. Solve it yourself. And it will crap out with a big error.
Right.
And I'm a fan of that. It takes some getting used to, because at first sight, you look at that, you think like, oh, what about security updates? Right? What if I pick version 1.6 and
raising your hand? I'll come to you in a second.
And somebody like an update is released in 1.64 or something, and that's a security update. The concern is, okay, how do I sort of automatically get that update? And the solution there is, well, you bump your minimum version to that, security update. But beyond that, it is surprisingly simple to wrap your head around. It's implementation-wise fairly straightforward. I don't remember off the top of my head, but let's say a couple 100 lines of code versus the 20,000 lines you're going to need for an SMT solver.
Yeah, right.
And it's fast. Like that's probably the most important thing, because really all it does is some simple checks like, oh, is this greater than that?
Greater than.
I think the core data structure is just a hash map of your package name to its version. Yeah. And then as you sort of crawl your dependencies, you just say, oh, is this one A compatible 2 bigger? Yes, override it. Off we go. That's basically it.
Let's say it sounds like a Dijkstra shortest path algorithm in there somewhere. Maybe I don't know. But fine. Not a hard one anyhow. All right, let me grab Jim here. Jim, you have a hand raised. Is it for real? I got no sound. All right, Jim. You got to fix your mic. Yeah, I show you as unmuted and no sound. All right, we're gonna move on, but
hello.
Oh, yeah, there he is. There you go.
Now I can hear nobody.
We can hear you. Doesn't help. Okay, fine. And he just
scare him off, Cliff.
I scared him off. All right, fine. He'll come back in a few, I'm sure. Oh, here's your version select one. Yeah, sure. I like the min thing though. That sounds, if it works for folks, for anybody at all, and Go is a fine anybody, I'll take it.
Well, I just wanted to say my solution to dependencies, which is you just always use the latest version. You literally just it just automatically updates.
That's just
and then you're like, oh, it's broken. Right. I guess I have to fix it, and then you fix it, and then you keep
No,
going
you
on.
fix somebody else's dependency if you're always updating, because they'll hand
Right,
you
so
broken
the
shit.
key is you have to be able to fork everything. So like nobody is upstream. You're the upstream. You're just,
That's-
borrowing their
That's
patch.
kind of the monorepo approach. Everyone uses the same version in the latest version.
Oh, Jim's trying to get back in, but he's connecting from New Zealand or something. We'll find out if he makes it.
I like the monorepo approach. Then you don't have to worry about versions. Just everything's the same. Always ahead.
Well, was the endlessly go to the top of tree? Like I'm trying to make a product for a client. Endlessly
How's it going?
Oh,
Better?
great.
Better.
Oh, okay. Yeah. Before we left the dependency issue, I had a different take that's not based on the versioning, but I wrote a web server, and the web server used CouchDB key value store as a middle tier. And then I took I wrote a little rsync to take anything and rsync it into the key value store as a hierarchy of keys and values. Then I took the source tree and the Maven repository and stuck it in the key value along with the runnable app. And CouchDB is fully replicatable. So once it's in there and binary and your middle tier web server is hosting the little bits of jar file that it needs, and your CouchDB HTTP is hosting the blobs, and the key value persistence, then you can replicate the entire project from the production to the laptop and back once it's deployed. So anyways, got lucky with that.
Yeah, it's like Git to deploy. Using Git as your deployment infrastructure.
Yeah.
Yeah, slightly before Git, but pretty close. Actually, yeah, I could do the Git repo with the rsync. Don't remember if I did.
All right. What else? I'm staring at XTCs. No, Inco's dependencies. I should not. I'll stop reading Inco code.
So, you just mentioned that the early version of openjdk, they have different GC APIs for different GC algorithms, right?
Yes.
So I'm just curious, what if we redesign those, those GCs for openjdk? Should it be better to, we have design these all these kind of APIs ahead of time? Because I think maybe the difference comes from the involvement of the GC.
So the issue is any effort put forward to define an API on write once, throw away code is a waste of time. So no one has a clue whether or not GC and Java is going to take off. So, and you can't, the first cut, and it's a, first cut of industrial strength GC. So there's just trying to make it go at all and be robust and reliable and fast and whatever. You're not thinking API. There is only one GC, it's only the GC, and there's only the JVM, and you're trying to make it go at all. So given history, going forwards, going backwards, there's no chance you're gonna have an API thought through or whatever. Going forwards, you have a new problem, you have a new solution, you have a new problem, you have a new solution, you keep going, keep going. Suddenly 10 years later, people are like, boy, this GC has fundamental problems. We want to replace it completely. And you look at all the hooks it's got in the system and it's a nightmare. Well, that's because that's how it got there. But that's true of every large project going forward. When you start it, there is no idea that it's going to take off or not. You have hopes, but they're never, many big projects just fail on the starting line. There's no point in an API to begin with. So that means every time you come through with a project like this, it's always, you have to stare hard and do tons of work to add an API to an old, large existing project, because the project wouldn't have been large and existing if you had spent time screwing around with API in the beginning. Now that we've done API things for GCs and a lot of frameworks in a lot of different places, going forwards new, say for AA, I will throw in a reasonable API for GC because I know how it's done. I've seen it done a dozen times. Back when Java started, no such animal. Now, where is it in the OpenJDK? It's a mishmash of, we've added a bunch of GCs. Several people made attempts to do a GC API. There is something that kind of sort of works, but if you dramatically change how the GC algorithm works, you need more work done. But hey, OpenJDK has gone through, at this point, you know, like more than a dozen, maybe 2 dozen GC algorithms. And you know, the last go round with ZGC or G1, whatever, touched a lot more places. It's probably pretty stable for, you know, here is a GC API.
Yeah.
It's not going to be pretty. It's going to have all this history behind it, but it's at least going to be stable. Be like LLVM's API, big, complicated, hairy, but stable, usable.
Yep. From briefly looking at the OpenJDK commits a while back, the interface is changing. So the impression that it hasn't changed since the very beginning, I think that's accurate.
Yeah, I thought ZGC in particular should have made significant changes. Anyone who does anything smelling like a read barrier is going to have a lot of changes. So Azul did a lot of read barrier changes. We did a lot of concurrent stack crawl changes, which meant you had to lock people in and out of partial stacks to do stack crawls and the like, do partial concurrent stack crawls. And these are all things that are only in there for the GC, but they don't smell like GC. It looks like, you know, I've stopped your stack from, you can't return from a function, because if you did, you'd be into the frame I'm busy rewriting or whatever. Stack hacking things. I imagine the escape stuff brings in a whole lot of new GC stuff. Like, I just take this thing and I've deduced that it doesn't escape except on this path, but if the compiler decides it's going to escape on that path, I have to inflate an object or something. There's going to be things there too. So that kind of answer, I mean, what I heard you say was, why didn't we do? And the answer is we didn't do because no one was going to do such a thing back then. But is that what your question was?
Yes. But actually, the reason that I make this question is that recently I was asked that, I was mentioned the Webassembly GC, right? So there's some people going to ask me if you are going to have GC for Webassembly, which is targeting at multi-language support. So maybe you need to have a universal GC interface for different GC languages, for different GC algorithms.
Yeah, right. Yeah.
Sounds difficult.
Yeah.
Yeah. I'm thinking, I remember last time you mentioned that and Cameron also mentioned that it may be possible to have a GC library, but the problem is performance. So for WebAssembly, I'm thinking, maybe we can have a standard object layout defined in WebAssembly and use different front-end compiler to compile different languages to fit that object mode in WebAssembly, and then we solve all maybe we can solve kind of performance problems like object inlining.
Yeah, the more general you try to make things, the less specialized it becomes, and you lose some of the advantages that you can get.
Agree.
Yeah.
So
agree.
When you're looking at a GC API, like object layout's like the smallest thing. You have to do it. It's straightforward. You have to be able to crawl your stack. That means you have to have interactions with runtime to crawl stacks. If you're doing concurrent, you have to be able to crawl a stack on a thread that wants to run, and you have to be able to stop it, or it is stopped, and then it wakes up because the IO is done and it wants to run again, but you're crawling a stack and mutating, and then it's crashed. So you have to have an interaction between threads and where they're running or not, and stack crawling. If you're going to do a generational collector, they're very common. You need to have something to do with write barriers, and that goes into the JITted code. So you have to have the hooks in the compiler, but how you generate a write barrier, so the compiler has to track pointers. That's a big piece of work, but it's understood. Now you have to have write barriers. If you want to have an algorithm that's not a snapshot at the beginning, but it's the other version, you're going to need a read barrier as well. That means everything where you touch a read, you have to do something magical, and you want the JIT to optimize the read barrier when he knows that it can't be null, or it's always a null, or he knows it's just recently generated, so he doesn't have to do a generational crossing check or blah, blah, blah. And you have to teach the JIT all these things. That's part of the GC API as well.
Yeah.
So there's a big complicated pieces here, and it hits the runtime, it hits the code generation, it hits threading models, it hits all kinds of stuff. There's concurrency issues as well. If you're mutating multiple threads running in the same heap, and I don't know if you're going there with WASM, and somebody wants to mutate a guy, and somebody else wants to read it, and the GC wants to do a phase flip on the thing, then you have to watch all those state machine transitions very, very carefully, and that's part of your API as well. So I would go in with the notion, eyes wide open. If you're writing a GC API, eyes wide open. And there are some historic ones floating around from the academic world where they at least touch base, what J9, what's the GC one done by the Jikes RVM?
Jack RVM.
But they have a widely published GC toolkit, which they've embedded into Jikes, and they have a large discussion, or I think a somewhat well documented GC API. I'm not saying you should follow that one slavishly, but you should be aware that it exists. And here's an example of the things that you have to think about. And I'm missing, it's like not mmix or MMTK.
MMTK something.
Yeah, MMTK. Yeah.
MMTK. No, that's it. MMTK. Here's the memory
here's the
management
paper.
toolkit.
I found the paper, maybe, I believe.
Yeah, I found the top level point on it. And there's pointers to GitHub. I'll throw the top level link in the doc if it's not already in there. It's worth at least surfing through what they're doing and why, and it'll give you some clues as to what goes in an API there.
Okay.
I'm gonna say, I don't know what this guy. Yeah, this is it. This is the right thing. MMTK core. There's the Jikes RVM integration, openjdk integration. Oh god, that's gotta be a nightmare.
Yeah, I remember the guys who is working on MMTK. They have a paper recently sharing a new GC maybe, and they are targeting to merge them into openjdk.
Oh, okay, cool. Yeah, they've done a lot of interesting GC work. We went back and forth. Like I knew most of these guys, and we talked a lot about GC algorithms and code generation and performance of GC, this and that, because they were hoping to get their stuff into Hotspot, but Hotspot's, API wasn't reasonably done enough to do any sort of merging from an external party without major internal engineering efforts. And that's improved over the years. So there's a real hope to think that they might be able to get their stuff in. Whether their algorithms are better or worse than anything else, I don't know, but there's a chance that they could at least run sort of apples to apples. Like all their history of their academic papers is they run Jikes RVM compared to Hotspot numbers. Okay, Jikes RVM's nice, but Hotspot wins hands down on all kinds of other fronts on it. So it's hard to get a good apples to apples on the GC alone. Yeah. Mark bits.
Okay.
Header bits. Yes, right. Yeah. New topic.
Next topic.
Or not, whatever. If you got more questions.
I got one, but I like to wait because it's not related to anything we discussed.
No, start up. We got. I'm going to shut the whole conversation down in 30 minutes.
Okay, so I just noticed earlier today that my tuple code is incomplete. And I was just wondering if you guys had any pain points with tuples, like implementing them or even returning them from functions. I have no idea, but I'm just messing with that right now.
So what specifically there? Because like Ingo has tuples. I have them up to 8 members.
It has tuples as well.
But the way I've implemented them is they are basically classes or structures, whatever your type for that is, and the fields are just named 0, 1, 2, 3, etc. And the syntax allows for that. Like you can actually technically define a method called 42 and do x.42, and it's like, oh, that's a method, let's call it. So it is, I think the best way to approach them is they are just structures like any other. It's just that their field names are numbers instead of alphanumerical.
Exactly what I'm doing.
Currently, the only way I can access it is by saying variable like a comma b comma c equals tuple, and it will just is there a word for like expanding it to those variables?
Yeah, syntactic sugar for parallel assignment breakout, right?
Or
So this is like time for Google Docs. I'm going to share Google Docs. We can throw some code examples in, and you'll find out.
Yeah, this sounds like a combination of pattern matching and wanting to have tuples, I guess. Because destructuring
there's
is
a word for it, like, oh, destructuring might be the word.
Destructuring, yeah, right.
Yeah, so currently that's the only way I can access the tuple by destructuring it. But I pretty much have no implementation of anything. I don't know if people are going to want to do like tuple.0 or like.
I support tuple.0.
Yeah.
Exactly. And I think I just heard Yorick say the same thing.
Yeah, so I think while Cliff is typing, there are two things here. You have, well, let's say three things. You have tuples as a concept, tuples as a syntax, and then some form of unpacking that. I'm gonna just call it pattern matching because that's basically what it is. But destructuring is also fine. Tuples as a concept is basically just structs with numbers as fields. That's I think, as far as I know, how literally every language out there does it.
Yeah, I currently implement it like that.
Right. Then you have tuples as syntax. That is basically a desugaring. You can do that two ways. You can, in your compiler, you parse it using your tuple syntax, and then you have a separate pass where you take those tuples and you turn them into whatever syntax you use for structure literals, for example. And that means that that layer needs to know, like, hey, if we have a tuple with 3 fields, that translates to an instance of the tuple3 structure, for example. And this is literally how I call, like, there is no tuple class in my language. There's tuples, tuple1, tuple2, tuple3, etc. Now you can do that as desugaring, or you can kind of keep it and do it later when you start sort of generating your code, because then you can maybe do certain type checking on it if there's anything special that you would need to do. Pattern matching is an entirely different subject. I'm going to add a link. I suggest reading through that once you have the time for it, basically.
Just for my sanity, so this is 0, like you can't use like a random integer variable for that. It has to
Can't use it. No, it's a constant.
It's
a constant value.
Yep.
Yeah,
I agree with that.
Okay, so that's just a field name.
Yes.
Okay, not an expression. So an expression is an array, and that has a different syntax, and you do other things with it.
I would like to add that you should have some code to support nested tuples and working with nested tuples, because it's.
Oh yeah.
No,
I forgot about that.
It didn't make any difference.
No
right?
different than a field assignment in a structure. Like if I'm in the middle of parsing one tuple, and I hit a syntax for another tuple, I just recursively call my tuple parser.
No. Regarding parsing, regarding working with nested tuples, flattening them.
You mean like algorithms for manipulating?
So that's.
I mean, okay, fine.
Could you give me examples?
It becomes really tedious when you are working with multiple nesting tuples, and extracting information from that becomes.
I would
really
avoid
tedious.
doing that in the first place.
I would avoid doing it in the first place as well. My theory on tuples is that mostly I'll use them because people won't have parallel returns. And then I'll give you a hard guarantee, that you get no allocation and you get multiple values returned from a function.
Yeah, I support multiple returns, so that's why I haven't touched the tuples yet, because I've just been doing.
I'm using tuples for my multiple return.
The other thing I was wondering is, so you guys have mentioned the dots 0, 1, and such. Do you actually want to access like the elements by like tuple dots, or because every time I used it, I just destructured it or pattern matched it and
Oh,
just used the variables. I
yeah.
thought that was like the most ideal way to use it, but
You have
did
to
you ever
have
have a need?
you have to have a way to break out individual parts if, for instance, you only want one of the parts. You called some library, it gave you an error code and something else or whatever, and you only wanted one of the parts. You said .1 and you walked away and you got the part you wanted.
You can use underscore. That's what people do in Go. It doesn't have tuples, but it has multiple returns. And if you don't want
Use
to
a underscore as a way to get rid of the part that you don't care for.
Yeah.
So
I've
if-
seen that as well. So that's desugaring, but you wanted to have don't want to have age in my little example here. Just throw it away.
Yeah, I'm going to write out an example as well. So if the only way to use the tuple is something like this.
Put something that where you're writing. There's 3 people writing tuple syntax.
The last code block.
Yeah, mine is the last one. So if I said the only way to access a tuple member is by destructuring them, would that like annoy anyone's use? Like, would that be annoying for any of your use cases? Because I can't think of a use case.
If the tuple gets pretty large, we have a problem with that.
Yeah, you'll have to, right. If somebody hands you a 26 element tuple back, you'll have to be.
Well, yeah, that's the
Bring out the
problem.
other
Like, I would say that's the problem, but
we discuss a approach in the last of the CCC. Someone earlier.
I don't
Yeah,
think
I
only
think-
having this destructuring is a problem. But then again, I don't use tuples all that much. But
I
Yeah, 'cause
think the
I kinda
counter
think
question
that's-
to this is that why not have both? Right? If you treat your tuples as structures with just fields, you get field access for free, basically.
Yeah, right. I have no code to do tuple field lookup that's separate from the structure one. That's perfectly the same code.
Right.
does
And
both
then for
field and-
destructuring, if you don't want pattern matching in your language, that's totally fine. Then you can do this destructuring syntax you have. For that, you do need to keep the knowledge that something is a tuple when you start type checking things, so that you can, because with a tuple, we have a sort of clear definition of the order of fields, right? If I create a tuple 10 and 20, we know, oh, 10 is field 0, 20 is field 1. With a regular structure, that might not be the case. Like if your language, for example, allows the compiler to reorder fields. And what you obviously don't want is for somebody to write, A, comma, B equals some tuple, and that to behave differently because the compiler decided to flip the order of fields around because memory-wise, that's better.
Well, I would just, okay.
Right, and so for that, at your type checking layer, you would say, oh, hey, we know that on the right, we have a tuple, so that later when we generate the code, we can generate it in the correct order, basically.
See, my concern is that if you have a member, something dots a 0, it's going to be, or even 1 or 2, it's just going to be weird to read and confusing. Well, I always got away with just pattern matching.
I see people use dot first and dot second. I think it's very verbose. And dot 0, 1, 2 is sort of short and easy, and I don't know. It looks straightforward to me.
Every time I see dot first, I get confused.
If at the first place you use tuple, you are going for a shorter syntax. So operator-like syntax would be the best. The closer to operator syntax, the more better it will work, in my opinion.
So Lynn has a question in chat. I can support, I could support tuple.length would just be field count. Same for structs. Number of fields. But you can't go access them via an array syntax.
I think the tuple length, again, if you just generate basically a class for every tuple length, then length would either be a field or just a method returning an integer literal.
Yeah.
So
like in syntax wise,
okay,
if you don't like x dot number, you can always do x brackets number, like typically for arrays. I think the important thing there is if you have a statically typed language, you want the syntax to be something that the compiler can resolve at compile time into a type. So that it knows, hey, if I do x.100, but my tuple only allows 2 fields, obviously at compile time that should fail.
Right.
Now you can do the
So-
destructuring. I think it's, I would say if you have a tuple, let's say less than 4 values, that's fine, because in most cases you probably will use those individual fields anyway. I think it's not super common that you have a tuple of 2, 3, or 4 values where you only care about one member.
Agreed. Yeah.
It gets annoying if you have more, but then you could make the argument, you shouldn't be using a tuple at that point. You should just use a custom structure, class, whatever.
Has anyone wrote a tuple that's more than 3 or 4 elements?
Oh, I have.
I haven't.
I have.
I don't remember. I support up to 8. I think Kotlin supports up to also 8 for similar reasons. They basically say if you need more than that, go create your own type. What are you doing?
Yeah.
So
So for me,
what-
it doesn't make a new type. So I don't care if I have 100 or 1,000. If you write your machine generate out a tuple of 1,000, it's not a new type. It's just another struct. Or all my
So why do
structs are
you-
anonymous or something.
Why do you have so many all the time? I think Cameron said it. I'm not 100% sure.
I'm sorry, I don't have so many all the time. I have one time written one with more than 8.
I thought I heard someone say they do it all the time.
I do short count.
Tuples are arbitrarily sized, so like they're as big as they have to be.
Right, right.
If I have a method that takes 15 parameters and I want to pass a tuple of parameters, then it's 15. Period. I mean, they are the right size because that's their job in life.
Yeah.
I think maybe we're slightly talking.
Well, there's another question I heard from Levo, which was, do you do, how often do I do big tuples? And the answer is rarely. How often do I do 2 and 3 element tuples? Happens kind of often, yeah.
Past a certain point, even just for readability alone, you want to give them names or have some other structure.
Oh yeah,
other than
there's
flat
definitely a
text.
huge code smell.
Right.
I had a reason for doing my very large one, and it was auto-generating code to connect between Scala and H2O. And I was doing things with like the count of columns, and the count of columns in the data structure was however many count of columns it was. But the API demanded I handed the tuple, so they got a tuple and it was large.
Yeah, I mean, there are 3 data structures that share a lot of surface area, but they're not the same data structure, and that is list, tuple, and struct. Right, and you can conflate them by choice, which is what Yorick was describing, I think.
I've conflated not list, but tuple and struct.
Yeah, I mean,
field names.
they're
Yes.
perfectly fine in engineering decisions to keep things simple.
And Lynn, no dynamic access to any element, such as the last one. They're all statically known, direct, just like a struct. Just the name isn't age or person. The name is 17.
Right.
Cliff, when you said you're generating the tuples, were you generating tuples because it was faster? I mean, was it an optimization over generating structs?
Yeah, it's because tuples are a common structure that people use. So I want to have them in the language. And it turns out that they share so much in common with structs, if you view them as I just did, or Yorick did, that the code sharing in the parser is trivial. So I have a very small amount of extra code. It's like 20 lines or less that lets me parse tuples. And I can go pull that up here. It's just not a whole lot of code, no matter what you do.
Well, my concern is mostly about if I should allow it or not, but it sounds like I should be allowing large tuples. So I guess when I'm writing my code, I should maybe allow it.
Do you have a limit on the number of parameters functions can take? Same limit.
No, but I do prefer having 8 or less.
Right. But it's the same argument, right? So if you don't have a limit on the number of parameters, then don't have one on the tuples. And I would agree with you. Having more than 8 parameters would be bad form.
There. Yeah, there's a code smell there.
I think the question that Lynn asked in the chat is sort of what I was trying to get at. So you can't do things like that, or my desire would be for a language to not let you do things like that, to access the last element of a tuple like that.
How do I get this thing to auto?
I think that a question, like, again, if you generate things, you can generate a function called last. So, like in my case, my tuple types, for example, they're not generated. Like the standard library defines classes called tuple 1, 2, 3, etc. And the compiler knows that, hey, if I have a tuple of 3 members, that translates to this class. And then it has some extra knowledge for type checking, stuff like that, right? You can just define a method on tuple 3 that essentially acts as called last, that acts as an alias for field 3, for example. In other words, tuples are not like arrays where the size is dynamic. They're statically known. So you can do all these tricks to just support last, first, halfway, whatever you want to do, basically.
Certainly you could do it.
You've already got the virtual indirection for the methods, so you might as well take advantage of it. That should work fine.
That it confuses me a little bit because if you said you have like a tuple 1, tuple 2, or whatever it was, but if the types were different, wouldn't, I mean, if you needed like 2 strings versus 2 ints versus 2 floats, it doesn't make sense to me that like a tuple name of like tuple 2 would suit all those.
So tuples have static types, so they're not going to be the same tuple being 2 ints and also in the same 2 fields, 2 floats.
So Levo, think of it as think of it like building a different template for each size of tuple. So tuple 1 has 1 type parameter. It's a template with 1 type parameter called capital T1, and tuple 2 has 2 type parameters of capital T1 and capital T2. I mean, and you just do that out to, and it sounds like Yorick can even do it dynamically. Like, yeah.
No, so I added a link. I'm not generating these classes dynamically. They just exist in the standard library. But my compiler does have knowledge that, hey, if it encounters the syntax for a tuple of 3 members, then when it's time to start generating the code for that, it knows, wait, so we need to create an instance of tuple 3. And the way I've done that is in my type system, there's not actually a specific type for tuples. They are just basically represented as a instance of a class. But then in my type system, that class has a flag set that basically is tuple is true, more or less. And then when you do pattern matching using the tuple syntax, it will check, hey, is the value that we are pattern matching against an instance of a class, and 2, does it have the tuple flag set? If so, if it walks and talks like a tuple, it's probably a tuple. And this way, you can prevent using the tuple pattern matching syntax for regular classes, where the order of fields, currently I haven't decided if I'm going to keep it or be able to shuffle it around, but basically, it will more or less remain unspecified. And so what you need basically is you treat them as classes, structures, whatever. And then you generate the types on the fly, or like I did, you just create a couple limited ones in your standard library. And you need a flag so that you can basically say, hey, was this structure created as a normal structure, or was it created using the tuple syntax? If so, we give it some extra permissions and whatever.
I'm very similar. I threw the code in for my extra code for doing tuples, and it basically says, while I have a new field, give it a field number that's 1 more than the last field number I've ever had, and it's a final field, and it's finally assigned. And then I look to see if there's a comma or not, and if there's a comma, there's another one coming, and I go parse the next one and loop. And I'm adding fields onto a struct whose field names happen to be 0, 1, 2, 3. So this is not a lot of code to parse arbitrary count, and there's no size limit for me. I don't have a separate type class for tuples of different lengths. For me, all structs are anonymous and they're all like C structs. If I want to inherit, I can from a prior, and that's subclassing. There's no Java class associated. They're just like C structs. And I guess I threw in an example of desugaring a nested tuple in the obvious way above the code for AA there.
This might twist a couple people's brains, but I was also thinking about how to declare tuples or multiple returns. Let's say, if I'm assigning a tuple to two variables, one of them already exists and one of them doesn't, should that be a syntax error or some kind of error?
I would claim you have a definition, you have a new definition, the two definitions collide.
Yep.
If I say X equals and later I say X equals again, am I
No,
reassigning
I mean, if I do A comma B equals tuple,
Yeah.
A exists, B doesn't. Should
Right.
that be an error because they both don't both exist
Okay.
or both don't exist?
treat A comma B equals tuple as two assignments. A equals something, B equals something. Now I have an assignment A equals. A previously existed. So if your language says A is mutable and I can overwrite it, that seems reasonable. You're just going to overwrite it. If A is a final assignment early on and you have a new assignment in the tuple syntax, you have a new assignment and you had a prior final assignment. So therefore should be syntax error. You're trying to reassign a variable.
But you shall not change
Scroll
the
down,
type. So
Cliff, scroll down the page a bit.
Yeah, okay.
So right
I'm
there.
claiming you should not, you should treat it like an assignment, which means you shouldn't change the type. It should just be another assignment. It should honor the rules for final or mutable or whatever your syntax is.
So where I say literal is an assignment, you can drop any of the types if that's already a declared variable. So let's say C were already declared, you just drop Boolean because it's like anything else. If you put type name, it's a declaration. If you just put name, it has to already exist.
It has to, and then you have to honor whatever the rules of the prior type is. So it has to match the correct type and it has to be,
And it uses bidirectional typing for all that. So it pushes the type from the left side to the right side. And yeah.
Right. So I'm treating it like this, like it's just another assignment. It's a series of assignments, but it's just another assignment, honors all the assignment rules.
Whoever's typing at the very bottom, I like what Go does. You have the colon equals for definition, and then you just have like just equals for assignment. I would not allow you to declare a variable with either one. That's kind of confusing.
Okay, my language is very strange because I want to get rid of auto and var. Like I want to avoid noise in front of a variable because I want people to create new variables rather than reuse variables. So the A equals value is declaring a constant or immutable.
Immutable.
And A colon equals is also declaring a variable, but it's mutable.
That's exactly.
I think what Go does is for constants, you have to say const A equals val, which is fine.
Yeah, I hate that.
For me, but
yeah,
for my language, I hate that because
constants are so rare. I think it's good to have some kind of syntax to say that it is a constant. But of course, everyone has their own philosophy.
Wait, Ganesh, what does Go do for mutable versus immutable, not constant?
Oh, I don't think Go has a notion of immutable.
Gotcha.
As far as I know.
So he's talking about immutable, not necessarily constant. Value might also be a constant, but separately, the first assignment is A is immutably assigned to val. And the second one, A is mutably assigned to val, so that you can later change A again.
My personal opinion is that this distinguishing is not hyper useful.
The mutable versus immutable?
Yes.
Okay, I will strongly disagree with that. Fine.
Oh, it's a controversial topic. Here we go.
Exactly. I use mutable variables in my code, but immutable variables are by far dominant. Like it's like 90% immutable, immutable, and 10% or less are mutable, and not counting for I equals I plus plus, not counting those. Those happen all the time.
I don't have a strong opinion for this one. I think both have benefits.
I have no idea how to make a code block, so I just wrote it. But So the weird thing about my language is if you do variable dot or variable open brackets, it's the compiler knows, or people reading can understand that you're accessing a member or you're accessing array, and you're not declaring one. So you could just mutate the variable by using a sign. But for single variables, equals specifically means declaring a new variable. So to change it, you have to do dot equals. So the problem I was having is it really wouldn't make sense to do a comma b dot equals if you want to declare if one of the variables is going to be new. So, and then if like, it's just weird to me that if A existed and B doesn't, both A comma equals, I mean, A comma B equals and dot equals, they both would not make sense. So I have no idea how to assign it in my language. I was thinking maybe A comma B like plain equals could just like over, it will keep the type, it would just mutates the variable if it already exists. But that would be like the one case that you're allowed to use equals when you're not declaring a new variable.
That quickly would become confusing. If the A exists and B doesn't, if it's in a local context, you just shadow it. But if in a larger context, that's declaring A somewhere.
Shadowing is not allowed in my language.
Well,
yeah, I mean,
that's why I was thinking
the challenge is you have a construct that's not composable, and you're trying to use it in a way that requires composability, so you're fucked.
Yeah, exactly.
I mean, it's really that simple. Like you have to either accept that, either accept it, or you go back and redesign the atoms by which that molecule is built. Right? Like,
I think it would be okay to do A comma B. One of them would be declared and one of them won't. But I have no idea what other people will think.
yeah, you're making exceptions, and at some point they bite you.
Yeah.
You have
but
to
those are your choices as a designer, right? Like,
well, the other thing is it would not let you do it if you defined it as like a mutable. I mean, as a constant. So if A is mutable and then you do that, you're probably intending it to change. So I think that exception would make sense, but it's not something I could play around with because it's not implemented. I'm probably going to implement it this week, though.
I have one question, Khalif. Is defining tuple this way, how you can refer to the whole tuple at once? You prefix it somehow, or
no, you just put another variable there. I'll do this in just in a second. It's
oh, it's like something.
Yeah, that's it. Yeah.
So
I haven't sorted out if I need to have that A comma B on the hard left-hand side only. It probably has to be on the hard left-hand side. Like that particular breakout, I don't know is ambiguous or not.
Again, my personal opinion, it's very easy to get carried away with various symbols, I think, but I think it's good to minimize that. I like what Java did with like, if you want like a final thing, you can just say final var x equals blah, blah, blah. Then that's fine. It doesn't introduce too much syntax.
Yeah, I want const by default.
I have simple assignment as final. And you're saying the word const for me, I mean immutable assign, and the colon is mutable. And I don't need types because I'm inferring them. And if you just throw the variable down, it'll be a new declaration.
Yeah, the problem with the term const, it's kind of destroyed by C++ because it means 17 different things.
Oh God.
Yeah.
So when Levo says const, like because it means everything, it means nothing. That's the problem with C++.
Right.
Yeah, I say const because I've been using C++ and people don't say immutable.
But const doesn't mean anything in C++.
Right.
That's, so do you mean that the variable is
What I'm
const,
used
or
to
do you mean
saying
that the
and
thing
what
that the variable is const?
what I'm used to saying and what I should be saying are two different things. And yeah,
Yeah, I know
I
what you mean
mean
not to be
immutable
saying.
most of the time.
For
No, I've had declarations that had 4 consts in a single declaration. So it's
Yes,
like,
yes.
what the heck?
And right,
I
and
mean-
go tease through what the hell it means. It's the problem is that, well, never mind. It's whether it was deep or not, or how deep it went, you know?
Right. Right. And it's always a cast away from not being const.
Yes, well, there's that one too. And then there's like, this is semantically const, but there's a caching layer which totally mutates under the hood.
Yep.
Right. But from a higher level point of view, I want it to be const. So I want to have some sort of consty-like thing that I can put in the type to say, yeah, this function doesn't actually change anything, except under the hood, it totally hacks the cache, which changes, of
There's a
course.
keyword for that, and I never used it.
Well, C++,
It's
I
mutable.
think, went through and people wanted that behavior, but they used the word const, but they would just cast away const, hack the cache, and then, you know, re-enable const, right?
You gotta be ultra careful with that, with thread safety and so on. But right.
Well, you have to be ultra careful because the compiler is allowed to optimize based on the fact that it knows that that memory isn't changing.
But like, and there's some modes, it's actually okay because I said const, and if the compiler cheated, it just meant I didn't update my cache. It didn't mean I was incorrect. It just
Right.
meant the next time I had to do it the hard way, I then did the hard work and set the cache. And that was okay as well.
And const in an expression means it has to evaluate it to get the result.
No, constant expression means that it won't change. So the next time that you run through that same piece of code, you get the same value, and the compiler is allowed to do
That I
whatever it
would
wants.
expect. So,
Right.
but yeah, the const has to be a value or a literal or something that never changes, or it can be an expression that
make-
has to evaluate to a constant.
Right, here's a pointer, and I say it points to a constant thing. And conceptually that's true, but my accessor function is doing a union find because I'm running a union find algorithm, and under the hood, he does the find equivalent, which is updates your local cache. Everyone goes through a one-step read barrier on a union find algorithm. And you, if you're not pointing at the top of the find tree, you roll up to the top of the find tree. So there's a little cache there that gives you the
This is
inverse
why
Ackermann
you can
good
like
time.
and hate a language at the same time.
But outside the union find concept, it's totally const. It's just inside there's a, so C++ got stuck discovering the hard way about this. And now, you know, how do we do it next time around? I don't know. Yeah, I guess Yorick, we'll probably call it shortly here anyhow.
I think what Russ did, since mutable variables are generally more infrequent, they force you to put mute in front. I think that's
I
also
don't like
sensible.
I don't like the mute. That's noise for me. Fine. Personal opinion.
Happens infrequently, right? So at least in my mental model, it's fine. It's better than having this additional syntax weirdness, like this.
I don't know. It's additional syntax. Why do you care the word mute versus a colon in front of the equals? What's the syntax difference?
My personal preference is against weird symbols. Just for
Okay, I'd claim colon's not a weird symbol. Every language uses them
Me too.
generously.
I like var and val because they're symmetric.
Yes, yeah, I hear that. I just don't want to deal. I mean, it's fine.
Yeah, it's
I'm
more
with
keywords.
Levo on this one. Short is good.
I never really understood why people had to put final on everything in
No.
Java.
It's
Okay,
just the wrong
my
default.
wrap-ups,
That's
but-
why, sadly.
Yeah.
No, but why would it matter?
Okay.
Like,
Because it's give you an illusion to be in a file.
but whoever makes the mistake of changing something that they didn't want to change, like, I don't know. It's just one that never made sense to me.
I always look at that, you know, when it's final on a field, if you want to start mutating it, right, and you're going to remove that keyword, now you have to question, well, is somebody relying on the fact that this is considered to be immutable, right? So it's that nice reminder that someone may depend on it. But
Okay.
final on local variables, I think, is weird.
Yeah.
I got a design question now.
Yeah,
You
but
guys ready?
That's what he was talking about, though, is final on local variables, like the Ganesh, right?
Yeah.
Yeah, final on local is weird.
That's just because the default is wrong. If you were to do it the Rust way, then it would be final by default. And then if you want it to be mutable, then you would say mutable variable equals.
Well, no, I think it's there is that the context of a local
Yeah.
should be small enough that you shouldn't have to have those keywords. And if
Right.
it's large enough that you're benefiting from them, you probably need to rewrite that block of code.
There are various opinions, of course.
Yeah, but there's only one that's right.
All right, moving on.
Levo has a question, maybe.
Yeah, okay. So speaking
So,
of
Camera.
weird variables or weird keywords or symbols,
Dollar and-
I want to get rid of this, but
Hey.
I'm not sure how to do it without
Bye.
making it noisier.
I'm trying to
Um,
mute myself. I don't know how. Don't worry about it. Okay.
So if you look at the bottom, I wrote s equals $, and then struct a struct
Hi,
name.
Austin.
I can
Why do
still
you
hear
need the
Crow.
$sign?
Okay, so the idea here is I don't want to use new because most people, when they hear new, they think it's going to be on the heap. The way I do it in my language is the compiler will choose if it's on the heap or on the stack or where it could just choose whatever it wants, really.
But-
It could even choose to put into okay, maybe this is going too much into detail, but if you're passing in a
That's
variable,
a
you might
lot
just put it into like the parameters instead. But anyway,
What semantic meaning does the $sign contain? What if I just removed it and just always use
it means you want to create a new variable that's structure, like struct name, like foo. I probably should have just wrote foo. But I want to initialize the members to 1, 2, 3. Like if it has int ABC, that would be set to 1, 2, 3. So the idea I had is if you're writing a function call, you could just do $ type name. Actually, that would be such a better thing to write. My type. Anyway, in a function, I could just write in $ my type and then the initialize variables, and it would just pass it as a parameter.
What is the semantic difference between $ my type brace blah, blah, and then without the
you could think of it as a $ as new, but it's not necessarily on the heap.
He allocates storage, but he doesn't tell you where he put it. It might be in registers.
And what's
If
the
you put it-
curly?
Oh, that's initialize. That's like initializing member variables. So I'm just gonna type in.
So don't see why you
that's
need
your-
the
It's your
$sign.
constructor arguments.
Mhm.
Well, if I don't have the $sign and you just type and you just pass in, it would, the compiler would be wondering if you meant to use, if you meant a variable called my type or the actual type called my type. So I just, and also there's some syntax. I think the initializer had some problems with my syntax. Like it would be too confusing because you could technically write, let's just write an if.
You don't allow type declarations in the locals code because most
So-
languages, they don't require you to provide the $sign. So I'm still confused as to why you need it here.
He's trying to
Yeah.
switch namespaces from the variable namespace to the type namespace. And he's
But
whipping
the
up the type
type
constructor.
namespace wouldn't make sense in this context, right? So
No. If I say if new in Java, if I say if new object, the new switches the namespace. So now object is parsed from the type namespace. Right? Whereas I
Yeah.
could have
you're
a
in the
local
context
variable
of a
called
variable
type
assignment, right? So you already know that it can't be a type or like
I think it's just easier if I talk about the if. So if you
Mhm.
look at this if statements, you can see that I'm declaring a new type, or yeah, I'm
New.
declaring a new data structure, and I'm initializing it with 1, 2, and 3. So if I didn't have the $sign and I wrote this, you would think the 1, 2, 3 is part of the if body, which is just really confusing. And I
You don't have
had the $sign just to
parens
make it
around-
clear.
Okay, so you don't have parens around your if expression test.
Correct.
So there's an ambiguity between these two because one says 1, 2, 3 is the true part of the body, which just evaluates 1, then evaluates 2, and returns a 3 for an if. That's reasonable. And the first expression of the if says, no, I am making a new, which I'm going to Boolean test for true or faulty. I got a pointer out of the new my type as a whatever, and now I'm truthy testing it.
Yes, this would just be completely illegal because you can't really convert my type into bool statements. But this is just for parsing the syntax.
So the error here would be I try to convert a pointer to a Boolean. That's illegal.
Yeah. But the reason why I had the $sign is because it would be more clear. Because what if you wanted to like add like what if you did something like
so somewhere in the
actually, I don't
world.
know. Well, anyways,
I get it. That's not
I
helpful.
wanted
Ganesh here.
Maybe
I wanted to do something.
If you make the parser a little bit more robust, I think you can remove the need for the $sign.
I agree with the puke faces. But anyway, the idea was in a function, I could just inline my declaration without using a variable. And I could just initialize the variables with the brackets. And the brackets would interfere if like someone did some funny business with the if statements. So for my parser, it was just much easier to have a $sign in front of it. I would like to get rid of the $sign, but the only way I can think of is by replacing it with a word like declare. But declare kind of looks ugly. So I have no idea how I would want to change syntax.
I want to look deeper into parsing. I think it can be done.
I have
$sign without any.
I did something. I mean, I achieved a similar effect, but I went a different direction. So at the time I declared my type as a type in AA, I simultaneously declared in the value space a function, which is the my type constructor. So if I say my type, I'm going to be up in the code block for AA here, is assigned a type, which is a structure which has fields X, Y, Z for your 1, 2, 3, whatever. That declaration declared a type and declares a constructor with the same name, which is now a function in the normal function namespace. So if I want to make a my type object, I call the constructor. So some pointer is equal to my type, and I have to pass arguments as a normal function called 1, 2, 3. And that is the constructor call, not anything to do with the type variable. It just happens to have the same name, but they're in different namespaces.
Yeah. So this is
here you're using curlies instead of
so the curlies are on the @ curly is a struct. So my type is a type. It can be I could just use an int. I could type it as a 17 or a string ABC or whatever. It's a type. I happen to have a type which is a struct. The struct has 3 fields. The default constructor for a struct of 3 fields is a function which takes the 3 arguments for the 3 fields. So that declares like a class with 3 fields. So class my type in Java where I have fields int XYZ, except I'm going to deduce the type of the fields. So they'll happen to be XYZ because I passed, one int because I passed 1, 2, 3, but just whatever.
Yeah, somehow every language managed to do this slightly differently. Some use like the braces for the struct initialization. Some like Java use like new with parentheses for the initialization, and everyone has their own way.
Okay, and I'm not sure what your square braces there are. Those are the types of fields.
This is the Scala equivalent of what
Scala equivalent. Yeah, okay, that makes sense.
You're defining a class, which is a type, but you also define a constructor, which has an apply method. It's sort of that's.
And it won't return a thing of type object. It'll return a thing of type.
No, it will be my type.
Yeah. Okay.
So you guys don't prefer like curly braces to show that it's constructing an object? Because I would initially think that my type could be a function.
It's already clear from the braces, right? Function calls use parentheses, or at least that's the way it should be.
Okay, so in the pointer equals my type, that's a function call to a normal function. In the my type equals colon, the equal says an assignment, the colon says it's a type. So in my type equals colon, I'm defining a type. And then I give a type which I use my struct declaration, which is @ instead of the keyword struct. And otherwise, it's pretty standard struct declaration.
Yeah, for the boolean, from a reader point of view, it's clear because you're using braces, and braces are for the struct initialization, and then function call you'd use parentheses. So the reader is not confused ever if it's a function call or if it's a struct initialization. So you don't need the $, or you should not need the $.
Right. I think there's a way to do this without the $sign as well.
Yeah, I think for a period I had a constructor and an initializer, which is not a good idea, and I just that's what I'm used to from C++. But
well, C++ has
yeah, I really want to change, since I'm going to change my tuple code or my parser for the tuples. I'm going to change it for this and also the on statements. But yeah, I really want to get rid of this. So you guys don't, like curly braces for. I think I heard someone say they like curly braces for initialization, but it looks like it would just be better just use function parameters to declare the type.
That's mainly a matter of taste.
Up to you. I think Go uses curly braces to do both initialization and type declaration.
So don't do whatever Go does.
Is it confusing though?
It's not confusing for me.
What's confusing is when either you're doing something that's deliberately different than languages that people know, or you're conflating multiple things into the same syntax, or or something like that. So I mean, consistency is kind of the thing that makes things less confusing.
So if I drop the $sign and I use the curly braces, that will be fine. That's not going to be weird for anyone.
You can try
The
it.
curly brace is the weird one, I think.
I'm using curly braces.
No, sorry. The $sign is the weird one.
Yes, the $sign is weird. I completely agree. But how do I initialize the type? Do I do curly or
you say my type curly brace 1, 2, 3 close curly brace?
Yeah, that's not a bad answer. I'm using a standard function call, so I use round brace. But curly brace there seems fine.
Okay, I think it's my if statement's going to throw up because it's going to think that the type initialization is part of the function body, but I can probably figure something out.
Well, no, wait. Are you initializing you're constructing a my type there? Oh, I see.
Yeah, that's someone intentionally messing up the compiler just to see what would happen.
You have a grammar ambiguity you have to sort out. That's the reason I did round braces, is because I didn't have a grammar ambiguity to sort out.
You can have like type aware parsing or like type agnostic parsing, and there's various trade-offs and whatnot.
Currently is agnostic.
Because I don't know my types typically while I'm parsing. I don't know what is a type while parsing.
That's my problem, and that's why I had the $sign to begin with. But I
think C++
maybe there's a way to tackle this
type aware parsing, as far as I know.
So when you look at my type definition, I say my type equals parsing the string my type gives me an id on the left-hand side of an assignment. If the equals, I still don't know if I have a type or variable yet. It's that colon, then now I know I have a type on the left-hand side. After that, I'm in a type context and I can do type like lookups.
And that would make
the Go answer of if you want to declare a type, you say type like space name of type struct.
And then you use the keyword type, where I use the colon after the assignment. You use the keyword type before the assignment, and I'm okay with that. Makes total sense.
I think it's easier to grep for as well. Maybe.
Maybe. Yeah. I haven't explored enough I haven't written code in Anger here to know that this is like bad or not. It was easy to parse. It was syntactically tight. It kind of had a symmetry to it because it was an assignment. It just happened to be a type assignment instead of a variable assignment. Is it otherwise good? I don't know. Maybe not.
Another funny problem I had was if I did something like this. So this clearly, I don't know what this means. To me, this would mean this array of 1, 2, 3 should be of type U16, like
I would have put the
unsigned
U16.
16.
So you have a constant array, and you put in the constant values, like make an array, show me your syntax for making an array where you're not going to tell me what's in the contents of the array. It's just an empty array and we'll fill it in later. An array of size 3. I want an array of size 3.
Yeah.
Okay, so you're not declaring a type here, you're making an array. So new 3 fixed length that's your variable name. Okay.
Yeah.
Yeah, okay. And an array of length n, you just put an n instead of the 3, right? Where n something I read from the command line.
So the funny thing I ran into yesterday was I accidentally wrote this and thinking that I'm creating a new fixed length array.
Yeah.
But it was actually doing this, which was
yes, you have an ambiguity.
There we go. One character change and the whole semantics change.
Yeah, so what I did was I just made it an error. So you cannot, if it's just 1 or 0 elements, it's just going to be an error to say the type because it's just ambiguous. People are going to get confused.
Yeah, but how do I make an array, a fixed length array of size 3? Oh, you put the $sign in if I want a fixed length array of size 3.
Yeah, so this is the question. If I'm just going to drop the $sign, how should I do this? Like giving the array a type.
It's ambiguous. It's ambiguous at this point. You cannot.
Right. So now change the syntax. And I have my theory and I have not tested because I quit doing arrays until I got my other types sorted out. But the parser for me will put the type probably after somewhere of the closer open curly square braces. So I don't know that that's, good looking or not, but this would be so here is an array of undetermined extent of size U16 for elements, and I don't like this syntax directly. I might actually this might be okay. So the colon says I'm a type declaration now. I'm declaring what type you are, and then I'm not ambiguous now. I can put the 0, 1, 2, 3s or whatever in there. So if I'm going to do a length, here's a length 5, and now I want to do elements in there, and then now I have your problem, and I'm going back and forth on how I want to sort that one.
My problem is when you declare the array as like a literal, and I'm thinking that if it's long enough, you're not going to be able to see the type if I have it at the end. So that's why I put it in the front. But I'm a little worried about like using a cast-like syntax. Maybe I could do that, but I'm not sure if people are just going to get irrationally angry because it would look too C++.
Oh. Yeah, I'm trying hard to not do typecasts, or at least not use the parens for typecasts.
Maybe I could just do something like this where I put U16 and then the array in brackets. Maybe
so that's
that
a
would
constructor call for me, which I could also do. In fact, that's not a terrible answer.
Actually, that might be a little weird because people might expect it to be a single var instead of like a.
Well, if I pass in a 5, not a square bracket 1, 2, 3, then I want an array of length 5 whose contents are unspecified, 0, whatever. I put square brackets. I'm passing in the 1, 2, 3. I want an array of 1, 2, 3.
Does anyone have does anyone have feelings towards the syntax, like how you should cast an array? I mean, how you should specify the type of the array versus.
So for me, I have declaration and I have constructors. To be consistent with what I've done with source structs, there's a constructor call, which is a function call, and U16 with open close like that, that's a function call. And as a function call, I pass in arguments. It's fine. It's a function call.
How do you declare? How do you declare a literal array like 1, 2, 3?
Well, you just did one. You have a function call where you passed in a square bracket 1, 2, 3. So bracket 1, 2, 3 built an untyped array which defaults to say int. Then it went into a constructor who says, I took an array of ints. I'm going to make an array of U16s out of them. And then, if you want performance, you optimize it away. Fine, it's easily optimizable. But otherwise, the semantics of that line, I think, is totally sensible. Here's somebody who's writing a tuple, and they're like, hey, let's declare this tuple an array of U16, which would be, you know, I'm claiming U16, I'm using the name of the type also as a constructor in the namespace as opposed to the type space. So U16 as friends, this is a standard function call.
Okay.
So now I can pass arguments to standard function call. So as an example, I might pass U16 of 5.
That would make me think it's a single element.
Whereas if I pass in a tuple or a square bracket like this,
I kind of like that.
that is my current suggestion as of 30 seconds of thinking. So that might change tomorrow or when I blow my nose. So, you know.
Yeah, so if I drop my $, I could probably just make the type like the way you did it. Like, yeah, I kind of like that syntax.
Okay.
It's very clear.
No.
Yeah, I think that syntax is fine. I just gotta find out how many ways my code will barf on me and complain and remove the $. But, yeah. I know the ifs will complain for sure, but I don't know what else.
So you have to experiment and see what does it fit in your imagination.
Well, the other week I found out that everyone hates my style of errors. So I think what I want and other people want might not be the same. I still implemented my errors, but
implementing
by default,
your language in compiler, you implement your vision on how programming should be done. So,
but it's totally fair to take feedback from other people.
This is like bike shedding,
certainly
though.
done a lot of that.
Yeah, this is bike shedding problems. This is not like actual problems.
Yak shaving.
Yak shaving.
Yak. Yeah.
Yeah. All right.
Okay, guys.
I'm about to,
I'm done.
About to declare victory for Coffee Compiler Club here and move on.
Yeah.
We have I lost my guest. I wanted to go say goodbye to. Now my wife's trying to buy me lunch on the way out of town, way back, wherever. It's time.
Yeah.
All right.
See y'all.
Okay.
Any last comments, or I'm gonna.
No.
All right. Till next week is all good.
Bye.
Bye.